Okay, I ended on boiling point depression. And so I'll go on to osmotic pressure. Osmotic pressure is the pressure which needs to be applied in order to prevent inward flow of water across the semi-permeable membrane. Really relating more to biology here, you would learn this with when you talked about hypertonic, isotonic, and hypotonic. And it would be referring to the water crossing over the semi-permeable membrane in the blood cell. Again, remember it's going to go until it reaches equilibrium. Desalination. There is not enough clean water in the world, and so one of the things is they're looking at building desalination plants, and that uses reverse osmosis in order to remove the salts from the water and produce pure, clean drinking water. It's in a process. We still haven't quite got it to a level at which this could be versatile across the world. We still have a little bit of it's more of a money problem, but in theory it would work, and we'd be able to take the ocean's water, remove the salts from it, produce clean water, and then we would be able to solve the world drinking problem. So, Jacobs Henrich von Hoff received a Nobel Prize in chemistry when he showed that dilute solutions followed in mathematical laws like gas laws. So again, we're finding out that there is a mathematical reasoning for why solutions do what they do. And I'm just pointing out that he received a Nobel Prize for that. Colloids are suspension of tiny particles in a medium. And suspensions are a mixture in which fine particles are suspended in a fluid, whether supported by buoyancy. You've seen this when you have whipping cream, muddy waters. Muddy waters are suspensions because you can clearly see the particles in there. Colloids are more like whipping cream because you can't really discern a difference, but you do have particles in those mediums. Tyndall effect is scattering of light, like fog. Fog is a heterogeneous mixture, and when you shine your beams through there, your light is bouncing off of the particles, which is why you should not use your high beams. The picture at the top is showing a true solution versus a colloidal solution, and if you notice, you can see the light beam in the red one, but you can't see it in the yellow one because the red one has particles which are scattering the beam. Colloid versus solution, it all comes down to particle size. That's what it comes down to. So just pointing out that your particle size has to be 10 to the negative 7 centimeters in order to be a solution, and then in between 10 to the 7 and 10 to the 5th is a colloid, and anything greater than that is a suspension. Coagulation is a method to destroy a colloid. You add heat, you increase the velocities, which is particles hitting one another, and you break them apart. You can also add an electrolyte, which will neutralize the adsorbed ion layers. And I'm just pointing out along the coast where you have your fresh water and your salt water combined, you get this coagulation occurring, which is what that discoloration along the coastline is. And the last slide is just pointing out the different phases. You have emulsions, colloid, where both phases are liquids. Sols and gels are colloids in continuous liquid phase with solids suspended in it. And a foam is a colloid gas that forms on the surface of a liquid or solid. So again, these are just some examples of colloids and suspensions.